Now we're here. We'll reach the spring equinox in 5 weeks. So why is the Earth round? It's a question of mass. The Earth's mass exerts such a pull that every part of it is drawn towards the center. But this doesn't work for asteroids. Asteroids are tiny planets, so small there's not enough force to pull together all their matter and form a sphere. On the Earth, which has a huge mass, the pull towards the Earth's center is irresistible and nothing can escape it. Fortunately for us, since this pull keeps the atmosphere, the air we breathe, around the Earth. It's the Earth's mass that gives us our weight, keeping our feet firmly on the ground and preventing our Australian friends from falling off into space. You feel this pull each time you have to climb the stairs. Whenever you try to move away from the center of the Earth, you have to overcome the Earth's pull. And when something slips from your hands, it's immediately caught by the Earth's pull and falls. They say this is how the Earth's pull was discovered in the 18th century. An apple fell on Isaac Newton's head, making him wonder, why? Because the enormous mass of the Earth attracts the small mass of the apple. So why doesn't the moon fall onto the Earth? And the Earth into the sun? The force of attraction isn't the only force acting on the Earth and the planets. Formed from this matter soup, the planets were subjected to a strong centrifugal push away from the center. Balancing these centrifugal forces and the pull of the sun, each planet finds its own orbit. The pull is strongest near the sun. The force of attraction is greatest for Mercury, just next to the sun. To remain in orbit, it has to move fast, 170,000 kilometers an hour, while the Earth only travels at 107,000 kilometers an hour. The Earth is further from the sun, and the sun's pull is weaker, so on our orbit, a slower speed is enough. Even so, this slower speed is 30 kilometers every second. Imagine traveling somewhere 30 kilometers away in 1 second. At the moment, we're getting 3 extra minutes of sunlight every day. Why? The Earth revolves around the sun, but the Earth's axis always points in the same direction. Our planet never loses its bearing. At the moment, the South Pole is in daylight, while the North Pole remains in darkness throughout its winter. But during our circular journey, the North Pole gradually leans towards the sun. So here, the sun, which seemed to travel on this path yesterday, rises more to the left today. At noon, it rises higher, and in the evening, it sets further to the right. Look for a marker when the sun rises and sets, and tomorrow you'll see it rises more to the left, is higher at midday, and sets further to the right. If your windows more or less face south in the winter, the sun, which is low in the sky, shines on the wall facing the window, but gradually the sun, which climbs higher in the sky every day, will shine on the floor in the middle of the room. And in the summer, when it rises highest in the sky, it will only shine on the floor just next to the window. Now in winter, the sun's rays reach the far end of the room. Look at these rays and imagine the position of the Earth in the solar system. Imagine your place in the universe. As the Earth orbits around the sun, its axis always remains tilted in the same direction. So the axis is a useful reference for measuring time and finding out what time it is. We can imagine the axis of the Earth jutting from the North Pole like a rod. And if we draw a dial on the ice, the shadow of the Earth's axis gives us the time. But there's no need to travel to the North Pole. We can make miniature models of the Earth's axis. These are sundials. At the North Pole, the rod which prolongs the Earth's axis will be straight, at a right angle, 90 degrees. In Stockholm, at a latitude of 60 degrees north, to be parallel with the Earth's axis, the rod must be tilted 60 degrees. A little further south in London, 51 degrees. In the Philippines, 15 degrees. And at the equator, the rod would have to lie flat on the ground. The ground is parallel with the Earth's north-south axis. No more shadow, no more sundial. But there are other types of sundials, all aligned with the north-south axis of the Earth. Although you don't feel the Earth's rotation, you can see it, not only in sundials, but all around you. Every house and every tree throws a shadow. You just have to look. As you follow the shadows, you'll almost feel the Earth's rotation. In the solar system, we're well acquainted with our neighbors, the planets, their position, speed, and movement. But comets come as a surprise. They're the ones we know, like Halley's Comet, which passes regularly every 76 years. But sometimes new comets appear, like Hale-Bopp in 1997. Comets are smaller than planets. They move in elliptical orbits. Some come from distant regions of the solar system, pass close by the sun, then head off again. As they approach the sun, they throw off enormous quantities of gas and dust. These substances form the tail of the comet, which stretches out in the sky like hair in the wind. Comet means hairy in Greek. The comets are little hairy planets. We tend to believe that when comets race through the sky, their body is in front and their tail behind. In fact, the tail always faces away from the sun, since it's the stream of particles flowing from the sun, the solar wind, that blows the comet's tail outwards. Without their tail stretching into space, comets would be invisible.